Hello, everybody. I'm very excited to be here today for the Improving Scientific Software Conference 2021 edition. Welcome. Good morning, good afternoon, good evening, good night, depending where you are. Feels like yesterday that we canceled this conference. Instead, it was a year ago. As you might remember, last year we canceled based on feedback from you that rushing to an online venue at that time without the opportunity of the in-person networking would have greatly diminished the value of the event. Um, so the good news is that this year we had enough time to learn how to do online conference right. So we learned all the advantages and disadvantages of online conferences platforms, and hence we want to fully exploit the pluses. Um, so one example of the pluses that we are exploited is the costs are reduced. So they are not zero, but thanks to our sponsors, you have been able to register for free, which it's something good. Speaking of the sponsors, Omnibond, a provider of cloud cluster and a high performance computing service in the cloud, generously paid for a Gatherly networking session. So that addressed the main concern that led us to cancel the conference last year. So I'm really looking forward to see how that turns out. There are too many people to thank for their involvement. So let me just briefly mention the multimedia folks for, you are seeing me because of them, and everybody in the organizing committee, particularly Teja, the real force behind this event. You most likely have interacted with Teja already. And then if you go to the website here, you can see who the other people in the organizing committee are. Thanks them if you meet them, if you know them already, or if you meet them at the networking session. And last but not least, thanks to the NCAR Directorate for continuing to sponsor this conference. So now switching gear, please adhere to the code of conduct, which was sent to you by email, and it is also on a website. And there, same place, you can look at the schedule, the abstract and title and abstracts of the talks, and mailing list joining details in case you want to join there. It's a low traffic mailing list. So we will have question and answer sessions for the talks, and you should see down here a Slido box where you can ask your own question or upvote the question that you care to see answered, because there might not be enough time to answer them all, and so the ones that have most upvotes will be prioritized. So without further ado, let's get started. It is my great honor to introduce to you NCAR Director Everett Joseph. He has a PhD in physics with an emphasis on atmospheric science from the University of Albany. Joseph has served as PI or co-PI on over 90 million in research grants from NSF, NOAA, NASA, and other agencies. He has been member of the Board of Atmospheric Science and Climate of the National Academy of Science, Engineering, and Medicine since 2014. And I stop here because if I tell you everything about him, you will have no time for his talk. So please, everybody, welcome NCAR Director Everett Joseph.
Thank you, David. And you are beginning to embarrass me. I'm so happy that you stopped. Thank you very much, David. And I want to say good morning to everyone from whatever time zone you're in. And it's really my honor to have the opportunity to really provide some opening remarks to this very important meeting for us here at NCAR. And first, I also want to thank the organizing committee, Taisha, especially for working with my team and making sure I get here this morning. Also to our multimedia staff for the work that they do and helping us to facilitate this meeting. As David said, last year, just about a week ago from today, last year was the first day that we started working from home at NCAR. And like every place everywhere else in the world, we shut down. And we have been working from home. I haven't seen my office in a year and a week. And so I know that it was at the time of this meeting last year, and as David said, a decision was made to not hold a conference, and certainly we were disappointed about that. And it's been as for everybody, for all of us, it's been a challenging year with certainly challenges and opportunity. And I'm really proud of NCAR and our staff in how we've made it through the year. I'm very happy that we have an opportunity now to have this conference, although it's virtual, and we've all been living in this virtual world for the year. And so it has its pluses and minuses. There's no opportunity for us to network while we're having coffee. And certainly you're not here in Boulder. And I think some of you might be happy that you're not here in Boulder because winter remains here in Boulder. We had on the order of 20 to 30 inches of snow last week, and it's snowing again here now. So maybe it's a good thing that you're not here for those of you who want to avoid winter weather this time of year. And so we're really happy that we have the opportunity to have the conference again this year, certainly virtually. And looking forward that hopefully in the future, in the coming year, we'll be able to meet again in person. So those are my opening remarks. I'm going to share with you, I have some slides, and I'm going to try to share those slides right now, which is usually a dangerous thing, but we'll see what happens. Here it is. Believe that's it. And yeah, so I'm going to just share with you some of my thoughts in terms of, and I know many of you have worked with NCAR, many of you know who we are at NCAR, but what I want to talk about is, who we are today, what's our strategic direction, what's driving our strategic direction today, what's the importance of that, and especially the importance of our continued partnership with computational sciences. And I'm going to talk about computational sciences, but certainly software engineering is a critical piece of that. And we have a long, in earth sciences or atmospheric sciences, we have a long historical partnership with computational science. And I'll argue in these slides that I'm going to share, I really argue that partnership is really more important today than ever before. And so the term that we've been in our new sort of strategic direction, we've been talking a lot about actionable earth system science. And again, I think it's about co-developing research solutions with the computational sciences. So what I'll start out with is really talking about what's driving the work that we do today. And, it's really about the threat that's faced by society globally by a range of environmental challenges that are really unprecedented and in some sense existential. And that includes, threats from poor air quality, severe weather, and severe drought, for example. If we look at just some very brief statistics here with respect to poor air quality, something like over 6 billion people live in situations of excessive air pollution. On the order of over 3 million people on a global annual basis. It's 3 million people on a global annual basis suffer deaths, fatalities at this scale due to poor outdoor air quality. In terms of severe weather in the US, just this past year in 2020, there was an unprecedented $22 billion in disaster from severe weather. And this was something and this is an increasing trend. This is something like the 5th or more consecutive year of severe weather disasters of this scale. And as we know, drought is certainly a concern and another societal threat in terms of water resources, in terms of agriculture, And here in the Western US and certainly other parts of the world, we suffer as a result of drought. We suffer in other issues. We suffer from the devastating consequences of wildfire. So Earth Sciences, our community, we really continue to work hard to help society become more resilient to these threats. And in that endeavor, in the work that we do, we really rely on scientific advancement and scientific advancement that's empowered by technological innovation. And when I think of technological innovation, I think in this sense, I really think of computational sciences. But it's not just about advancing our science from technology and the specific scientific work that we do. It's also about new paradigms of how we work together. It's really important to us advancing our science, and that's something I want to really incorporate into my thoughts today, and especially how we work with software engineers, how we work with the computational sciences. So it's really a shared responsibility with computational science and software engineering to advance Earth system science discovery in actionable ways, really for a more resilient society. So what I'd like to do is talk about our new strategic plan and how our plan is really positioning NCAR to be a leader in advancing actionable science for the benefit of community in partnerships with other disciplines, and in continued partnerships with computational science, and how we're leveraging computational sciences to do that work. And so if you, these are some big themes, central themes in our new strategic plan. So again, we sort of focus on fundamental research. You know, at NCAR and NSF, what we do is we really focus on fundamental research, but fundamental research that really enable actionable Earth system science discovery. And there are three big themes here. One is building on our core strengths. That's our core science and facilities and community models. Building on those strengths that we have, not moving away from those strengths, but placing. The other big thing that we have here is really evolving our science to really place greater emphasis on interactions within the Earth system. And what it is, it's a recognition that from our beginnings, NCAR and our community is focused on atmospheric sciences. However, we've been slowly evolving more to emphasizing Earth system sciences. Investigating the Earth as a system and not only focusing on one component on the system. In order to advance science in one particular part of the system, one component of the system, the atmosphere, for example, we really need to understand how the Earth interacts as a system. And so it's that recognition that really underlies this, this particular theme. And the last theme is advancing actionable science. And again, it's sort of, in terms of actionable science, what we're really talking about is use-inspired science for the benefit of society. And what we, in this theme, in this thematic area, what we do is we really want to sort of think about what we mean by actionable science and developing the methodologies for actionable science. What are the drivers? Setting aspirational goal for actionable science. Actionable science isn't actionable just because we say it's actionable. We're doing something that, benefits, that we think benefits society. Doesn't mean that it's actionable. There's a methodology to actionable science. And so in this theme, we're really promoting, certainly at NCAR and within our community, efforts to really develop science in a rigorous way that's actionable. And so that's really what that theme is about. We have a set of themes that we call positioning NCAR for success, and it really has to do management and organizational goals that we think are important in supporting scientific excellence at NCAR and the work that we do. And so it includes fostering a diverse and inclusive workforce, building strategic partnerships with universities, federal agencies, private sector, reimagining those partnerships. It's not that NCAR has a history of having very strong partnerships with the community, certainly with the university community, but it's really in reimagining those partnerships for the 24th century and for the challenges that we face and the type of science that we want to do. Education and outreach is a core thing that we do, and so again, developing new strategies for how we engage the community in terms of education and outreach, and how we focus on early career scientists. And that last theme, fostering strategic integration, it's more sort of looking internally at NCAR and how can we organize ourselves in ways that really strengthen the science that we do. So integrating more across our silos, and modernizing our management system, really to enable us to deliver the excellent scientists that we have a history for delivering. So specifically as it relates to computational sciences, and we view this as a cross-cut across all themes. And the question is how do we really effectively harness the data and computational revolution that's taking place? And how do we harness that to transform Earth system science discovery? And this we spent a lot of time, believe it or not, it looks like a simple image, thinking about developing this image. And really what we want to sort of illustrate is it's bringing together, if you will, of Earth system modeling tools and solution, and empowered, bringing it together with data science, artificial intelligence, exascale computing, and cloud computing. Again, leading towards Earth system discovery and solution. And when we think about that, what we think about is sort of adopting, and this is going back to what I talked about earlier in how we work together and how we organize ourselves. And we're thinking about is sort of adopting co-development methods of how we work together, and also relying on systems engineering approaches. And it's really approaches that integrate physical science, mathematics, computational science, data science, and engineering approaches towards this Earth system discovery. And this is in contrast to sort of what I call the value chain approach of how we have traditionally done science, where we do things and we hand it off to another discipline. And so there's this value chain towards a product. This is a more convergent approach where we work together. And so we're trying to adopt, these methods exist, and in NCAR, we're trying to sort of organize ourselves and adopt these methods towards developing the solutions that we need to develop to advance our science and to impact society. So what I'm going to do is just give you a few examples of exciting work that we're doing at NCAR, and certainly in partnership with the community, and work that we're developing that really relies on software engineering and computational science. This example is something that we're really excited about. Has been under development here at NCAR for some time. And it's a new platform, a phased array radar platform, and it's an airborne system with dual Doppler and dual polarization capabilities. And so it's an airborne radar on our C-130, and it really will advances our ability to really get information and get data and to probe deep inside storms and convective systems, to understand, to get more information about dynamical processes and microphysical processes that take place and interact within these systems. And that information is really important to enable improved understanding and predictability of high impact weather events. And also, it also will enable us to better improve our representation of cloud and cloud processes in our Earth system model. Needless to say, this system will generate an unprecedented amount of data. So processing that data, working with that data, getting that data rapidly into models will require significant software engineering, innovation, and applications to enable us to do that and really realize the benefits of this system. This is our system for integrated modeling the atmosphere. We call it SEMA for short here at NCAR and in our community. And it's really a modeling, a new modeling paradigm that's been emerging at NCAR that really equipped us to better enable actionable science research. And the developers, articulated as enabling frontier science across communities. And again, we're going back to not only the technology and the science, but it's really about how we work together as well. And integrating across communities is an important theme here. And SEMA does that in a big way. It's coupling climate and Earth system modeling to meteorology, to chemistry, to geospace, and to polar sciences. Again, and in sort of advancing this sort of system approach to predictability. SEMA is a configurable system, and it's not one single model per se, as sort of we've traditionally thought of community models. It's an atmospheric model within Earth system model with a minimum set of interoperable components. So the way it works really facilitate communities working together and really facilitate efficiency in that work. The figure on the bottom right is an example of SEMA within an Earth system model, and you see the SEMA components of the physics and chemistry of the system, as well as the dynamic cores, the various dynamic cores of the system. This is an application of, this is a particular application of SEMA, and it's in a partnership with Colorado State University. And the project is called the Earthwork Projects, and it's really to make this very high resolution Earth system coupled model with, particularly with meteorological, convective scale and meteorological applications. NCAR's role in this is contributing to the atmospheric component of earthworks and developing the atmospheric physics components for GPU application. The earthworks atmospheric configuration really will rely on SEMA, as we talked about in the previous slide, how the configuration of the physics and the dynamic core. And this application, it really demonstrates the capabilities of SEMA being able to contribute to community science and also enabling us to incorporate community science in what we do here at NCAR. This is another exciting example of a convergent approach to actionable science. It's a partnership with the NSF AI Center at Oklahoma, and it's the AI Center for Environmental Sciences. And this is an example of what we call is really deep research across different disciplines. So it's a great example of actionable science. So it's deep research across disciplines to really solve an important problem in Earth system science. And the development is this sort of cyclical development process. And so it involves the three main components. It involves trustworthy AI, environmental science use cases, for example, in terms of hail, in terms of winter weather, in terms of coastal fogs, are the use cases or the initial use cases that will be applied. And then it also involves risk communication. That's important for decision making. These disciplines come together in a convergent way where there's deep research within the discipline, but interaction across the disciplines to really create new knowledge and to really create actionable science, if you will. One example of that is the application of AI to weather data and highway data to provide information in terms of impact to users or for decision making. And so we're really excited about this particular research because we think it's a really strong example of convergence research, actionable science research in terms of convergence. This is another great example of actionable science research. It's a collaboration between NCAR and UGA. And it's focused on providing visualization. Actionable visualization is, if you will, as a means of effective communication and producing actionable response by communities that are under threat from, say, severe weather. In this case, from storm surge. So this research, again, what it does, it's combining data, it's combining surge information in terms of from modeling. It's combining social science with a focus on vulnerable science and the use of information and risk communication. And it's also combining work from spatial sciences, GIS, 3D modeling, and data interoperability. I'm going to show a video in the next. So what it's doing is provide this information to focus groups to really understand how people take protective actions in response to this kind of information. And typically we provide this information through text or through static graphics, but providing this information in 3D animation, the studies have shown has been really impactful in really causing people to take protective action. And so this realization of this information is really critical, again, in decision-making of emergency managers, and again, in causing the public to take protective action. This is an example of a simulation of a LES model over Oklahoma City, and it's the GPS technology that really makes the LES application in this sense very practical. This system is called FastEddy system, and it's developed by our research application lab in partnership with our CISL lab. And this GPS application of this system really makes this modeling operational. And it has application in terms of energy forecasting for drone operations, for example, which is a new and exciting application there's great interest in. So so I know I'm running out of time, so I will wrap up quickly. So thinking about the computer sciences or computational sciences, technology that enable all this research that I just talked about, we're very excited about our new supercomputer that we'll be bringing online in 2020. It's a 19.8 petaflop system. It's 3x over our 3x speed of scientific computing and performance over our Cheyenne system. One capability that we're really excited about is that the system is configured. 20% of this system is configured for GPU computing, and so we're really excited about that. And we think that configuration really will help enable some of the sciences that I just talked about. And also other configuration of the system is in cloud bursting. So here's a slide that I stole from our CISL group with regard to taking advantage of the GPU computing. And at NCAR, what we're really saying, we're on this path to exascale computing, which again enables the science some of the science that I just talked about. And that involves GPU computing, it involves refactoring code. But again, thinking about the human factor, it's also important. Training and education for this capability is really important. And so that's kind of where I'll focus here, and it's really about managing the hardware, the software ecosystem, the user environment. Um, but 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 what's a really important thing for us to focus on, and our team is really providing leadership on, is training our scientists as well as our computational team for this capability, which will really be important in terms of us really harnessing and taking advantage of this capability. So it's here at NCAR, but it's also within our broader community beyond NCAR. So what I'll do is I'll wrap up where I started and sort of repeat that our Earth System Science community really continue to focus and work hard to help society become more resilient to these existential challenges that we face. And again, it's a partnership with a number of disciplines, especially computational science and software engineering. And it's a shared responsibility in terms of really meeting this challenge that's important to society. So I'll stop there and stand by for any questions. And thank you very much for your attention.